What? I can't turn my stuff down. What'd you say?
I was hearing like noises.
I know it's someone's not muted.
Oh, okay.
Whoops. All right. Hey, folks, real quick, we're going to do an audio check for the YouTube feed. Julie, let us know if you're picking this up and if it's going through. We'll just walk around for our presenters. Eric Roberts, moderator. Kathy, do you want to introduce yourself?
Kathy Higley, first up.
Jeremy?
Jeremy Davis. How's everybody doing?
Frank?
And Frank Johnston, and clean up. Jeremy?
Oh, yeah.
I can hear you. We're making sure everything's good on the YouTube side, which has a slight lag to it. Julie, are you able to pick up everything?
That's not a good sign there, Eric.
Oh,
Yes, everything's fine.
Everything's good? You're good?
Yep,
All right,
we're good.
Go back to the video. We're going to go back to the video and we'll start our meeting in about 4 minutes.
All
Thanks,
right.
guys. Good evening, everyone. This is Eric Roberts. I'm with EHI Consultants, and I'm the moderator for tonight's DOE Virtual Public Meeting on the Portsmouth site for the U.S. Department of Energy. Tonight, we're excited to have this fantastic agenda we're going to walk through, a chance for us to continue the discussions we've had over the last year. This is the fourth of, actually the eighth meeting we've had, 4 sets of 2 meetings where we've got the opportunity to talk about what's going on site at the Portsmouth site, what's happening with the air monitoring program and how data is being collected and what that data looks like. And we're also spending some time talking about what that data means and putting it into context. So that's our plan for tonight. Our speakers, we're going to have Dr. Kathy Higley is going to start with us tonight, and she's going to walk us through the understanding of risk and what air monitoring data, that put those numbers into context, what we're looking at and what we're talking about, and how it affects us as neighbors and as workers and as the environment around us. We're going to follow that up with Jeremy Davis, who is the site lead for the Portsmouth site, the acting site lead, and he's going to talk to us about what's going on site, all the key projects. He's going to update us on the progress, the tremendous progress they've made in the D&D of the X326 building, and kind of what's going on with building the waste cell and all the great projects he's got and he's managing there. And then we're going to follow it up with Mr. Frank Johnston. And Frank is the director of the Environmental Remediation Program for Flora and BW in Portsmouth, FBP. And that's the main contractor who does the majority of the cleanup work on site. So you're going to see, Frank's going to talk to us about the real-time air monitoring program, the co-located monitors, and what the most recent data looks like as that's been processed and comes through. So we got a lot to cover for you tonight. It's going to look and feel a lot like some of the previous meetings, but where everything's being updated. You're going to see this continual growth and evolution of the project and of the program and of the data as we go forward. So that's kind of exciting as we've looked at what we've accomplished over the last year at the Portsmouth site. So we'd like this really to be a two-way kind of conversation tonight. That's the plan, is that this is, even though we're in a virtual format, that this is more of a continued dialogue. Donnie, if you can hit the next slide for me. We're going to give you opportunities, if you're watching at home, to participate with us, whether you're watching on YouTube, and we're glad you're there, or if you're with us on the Microsoft Teams virtual platform, and we're glad you're here if you're with us. We're thankful that you've taken a little bit of your time to participate tonight. If you have questions, either now or if you, throughout the presentation, develop questions, multiple ways for you to share those with us. One, you can always email us at ports-demo-questions@pppo.gov. Quick and easy. Any questions sent there, we will gather them. We'll see what we can address tonight verbally. If we can't address it verbally, if it's more nuanced or if it's a longer answer, we'll get written answers, and you can find those at portsdemo.com. portsdemo.com. If you want to, though, we would love for you to participate more actively with us via the chats on either YouTube or on the Microsoft Teams. So if you're on YouTube, on the bottom right-hand side, there is a chat function if you're watching at home, and you can just type your question in there. And that would be a great time, if you don't mind, to just test out the chat feature on YouTube. Maybe throw in your name and where you're from, and let us know who else participating with us online. We've had up to hundreds of people watch the videos over periods of time, and so we would love to know who you are and where you're located. Same for those that are participating on Microsoft Teams. If you look on your Teams window, there'll be a little dialog box, little squiggly circle, and it's got some lines in it. You can click on that, and it'll open the chat feature. And you can just type in your question, which would be a great time now for you to quickly just throw in a name and where you're from. So I'm Eric, poorly spelled, and I'm in Kentucky. Boom. So you throw in your name and where you're from, and we can all follow along right there in the chat feature. If you have questions throughout the night, that's a great place to throw those in, and we'll try to address those at the end of the night. We'll go through our presentations tonight, and then we'll take if needed, we'll take a short break and kind of filter through the questions. If there aren't many questions, or if it's something we can go straight into, we'll go straight into the Q&A and then we'll have a public comment session where if you're available on the Microsoft Teams platform, we'll give you the opportunity to kind of raise your hand and identify yourself. We'll open you up as a presenter, let you turn on your microphone, and share your thoughts and comments with the Department of Energy. We'll go over specifics on that as we get later in the evening, but we wanted you to know that there is a time for public comment during tonight's meeting, but that'll take place roughly an hour and 10 minutes from now after the end of the presentation. So with that, I think we are good to go. We're going to slide forward. We'll come back and we'll cover the public comment protocols as we get towards the end of the meeting, and we'll do that next. But first, we're going to bring up Dr. Kathy Higley, who is with us. Kathy has been with us, for several years now, and is truly a voice that's respected across the country as it comes to answering questions on understanding risk and managing risk. And she's been a tremendous asset to the Portsmouth community, and we're glad to have her with us again tonight. So Dr. Higley, the floor is yours.
Thank you very much, Eric. And I refer to myself as a seasoned health physicist, which is another way of saying I'm old. But I'm a professor in the School of Nuclear Science and Engineering at Oregon State University. And I'm currently serving as the interim director for the Center of Quantitative Life Sciences at Oregon State. I have a PhD in radiological health sciences, and I've done work in contaminated environments all over the globe. And I very much enjoy trying to explain issues related to environmental cleanup and risk. So if I could have the next slide, please. Thank you. So you're going to hear a lot tonight about both radiological and other compounds that are being measured around the environment at the port site. And you'll hear discussions about exposures for workers and exposures for the general public. And the big point I think that you should take away is that there are standards, and it's not a one-size-fits-all approach to setting standards for controlling risk. And the standards for the workplace are different than the standards for the general public. And oftentimes we'll also have standards that are different for areas outside of maybe extreme recreation or things like that. And there's a lot of thought that goes into developing these standards, and so it's not surprising that the values vary. If I could see the next slide, please. You're also going to learn a lot about the approach taken to monitoring for these contaminants in the environment. And again, there's a lot of thought that goes into this process. You'll hear discussions about both close-in monitoring locations that are put right next to where the demolition work is taking place, and also monitoring sites that are located on the perimeter of the Portsmouth site. And the placement of these close-in monitoring stations and the ones that are farther out reflect what we know about the science regarding dispersal of contaminants into the air. And typically when you are knocking material down, you're taking apart a building, you're going to see the highest concentration very close in to where the work is going to go. And so at the Portsmouth site, they have multiple movable monitors that follow the work activity. And the process for using these monitors and kind of knowing where to set them up comes about because the DOE sites actually talk to each other and they learn from each other. Past practices that have taken place at another site, they've learned how to maybe improve on that process a little bit so that the work that's being done here is even safer than what has been done somewhere else. So the concept is with these movable monitors, you keep them in close, you're protecting the workers. That's the information they're collecting, is to protect the workers. But also you have perimeter monitoring stations, and their focus is to protect the public and the environment. And typically, the sampling periods, the sampling volumes may be different because the concentration of contaminants are expected to be higher closer into where the actual activity is taking place. So you may see different detection limits, different sampling volumes, and the like. Next slide, please. So as I mentioned, placing the monitors, it's not just a random process, but there's a lot of thought and actually data collection that goes into the determination of what's the appropriate place to put a sampler. And Department of Energy and other sites collect information on meteorological conditions, wind speed, wind direction around the site for all times of the year. And one of the ways they display it is something called a windrose, and that's the circles that you see up in the sort of the middle of this picture. And it's a nice graphical representation that tells somebody who's looking at it the predominant direction that the wind comes from, and also the wind speeds that occur from those different directions. And using this information, you can determine, all right, I need to put most of my samples maybe in the northeast direction, or I need to have it equally spaced around the site because it seems to be a pretty uniform field of wind patterns. And this data can be collected for daytime averages, nighttime averages, monthly, quarterly, annual, decade long. It just depends on the use. So this particular graphic is one of the more recent ones. In addition to that information on how the wind patterns are around the site, then you can also use computer calculations to help you figure out where your people are most likely to be exposed. Because sometimes if you're working on a source that's elevated above the ground, even 30 or 40 feet, it may take a little while. The wind may push it away from the site, and it may take a little while for it to actually come down and get close to the ground where it could affect people. So use these computer models to predict where your locations for sampling should be, and then you also go through the process of sampling just to confirm, yeah, these are in the right spot. Next slide, please. Now, with regard to the standards for exposure, in radiation protection and in occupational protection in general, they consider both exposure of the workers and exposure of the public. And as I mentioned before, those standards can be different because the occupational exposures generally think that exposure takes place over 40 plus hours a week, but also the group of people that are typically exposed are roughly 18 to 70 years, what we would call sort of a healthy worker range. And so the exposure for the workers may be a little bit higher, well, generally is higher than would be allowed for the general public. The public, we assume that they're exposed 24 hours a day, all of the time, and also that the people that are exposed include the very, very young and the very old, those that are quite at risk, sensitive subgroups, for example. And so the result is you have different exposure limits for each group, and generally the public limits are about are fractional, 10% to 0.2% of those that are used for the workers. Now, the other thing I'd like to point out is that there are these limits for exposure that are out there, but I want you to pay attention when you see some of the data that's being presented for the site. It's very common for sites to actually set administrative limits that are less than the legal limit, and that provides them a little bit of protection in case they get close to a limit. They don't ever have to worry about exceeding a legal limit. But then if you look at the data that's being presented from the gentlemen that are going to follow me, what you'll see is that the concentrations are in general quite low and far below these regulatory limits. Next slide, please. So you'll also hear more about what's being sampled. It includes metals, it includes radionuclides, it includes minerals like asbestos, and also volatile organic compounds. Now, I started out my life as a chemist, so I love the periodic table of elements. So the little black circled elements are the metals that are being sampled. The red ones are the radionuclides that are being sampled. Next slide, please. So one of the other things that you have to consider when you set up any sort of monitoring program is that you're looking for constituents that you think your site is going to contribute into releasing, but you also have to be aware that there may be other sources that could contribute to the background signature, even if your site hasn't done that. So for example, for metals, is there a geochemical, geologic feature in your environment that might contribute some background sources? Are there human activities, an electronics plant, a coal plant, vehicle exhaust that might also contribute to the signature? Because you need to tease out coming from the site versus what is coming from other sources. For radionuclides, it's the same thing. Uranium is a naturally occurring radionuclide that is all over our globe, and you can see elevated sources just from natural outcropping, if you had mining activities nearby. Some fertilizers, some commonly used fertilizers actually have elevated levels of uranium. And then there's also nuclear activities, such as at Portsmouth. And similarly, technetium is a radionuclide of interest that they monitor for, but it has been part of fallout, and it is also from other nuclear activities. And then finally, things like asbestos. There are natural sources of those in the environment, as well as historically is commonly used. So you need to understand, are there other contributors to that signature that you're monitoring? And similarly for volatile organics. Next slide, please. Going back to radionuclides, as I said, uranium is naturally occurring. It's all over the world. And we're exposed to these natural sources of radionuclides and also naturally occurring radiation. The two images, the top image of North America shows just how our radiation dose from naturally occurring radionuclides in the soil varies across the United States. And that's largely just due to the changes in geology. And some minerals are quite rich in potassium, which has potassium-40 in it. Some minerals are quite rich in uranium or thorium. And so all of those contribute to this incredibly complex radiation field that can vary considerably by an order of magnitude. We also get radiation coming to us from outer space, from the sun and from the cosmos. And in general, the closer you are to the sun, the higher in elevation, the less the atmosphere actually serves as a radiation shield, and so you'll get higher doses, and also typically as you move further north as well. So all told, combined, on average across the United States, our natural background doses are on the order of 300 millirem per year. Now, in addition to that, people take advantage of medical services for diagnostic x-rays, for a variety of treatment, and on average across the United States, your dose may vary considerably. Medical exposures are around 300 millirem per year. So again, the average for the United States is about 600 millirem a year. And in comparison, if you look at the annual site environmental reports that are published for the Portsmouth site, they calculate what the likely contribution to dose to the public around Portsmouth, and they estimate that at about 1 millirem a year. So the contribution by the port's activity to the general public is a tiny, tiny fraction of what folks on average get both from natural and from medical exposures. Next slide, please. So this slide, it's a little bit complicated, but it's meant to kind of convey what we know about radiation exposure and what the risks are. So if you could advance it one, Charles, I appreciate it. So we know with really high doses and high dose rates, you can cause very severe effects. But we also have areas where we can measure the dose, but we do not see any sort of adverse effects at all that are happening. So again, just to kind of go back and recap this, in the really, really high dose region, we can observe effects. But in the low dose region, all right, what we do is we use mathematical models to calculate effects. We don't observe it, but we calculate it. Environmental radiation falls in that range. We also have exposures from diagnostic medical procedures. They're also where we can calculate risk, but we typically don't observe it. Now, if you have radiation therapy, say for cancer, we know you're going to see effects because that's the intent of the therapy. And all of our understanding of the risks comes about from studies of groups like the Japanese atomic bomb survivors, from those people exposed during Chernobyl, and to a much lesser extent from some of the releases outside of Fukushima. But the important thing to take away from this is that the natural environment is in a region where we calculate effects using mathematical models. We don't observe effects. And the typical soil cleanup goals that you see for the Department of Energy are way, way lower than any area where we can observe or really expect any sort of effect. Next slide, please. So you're going to hear again today about the process and the procedures that are being used to take the site towards cleanup and ultimately to redevelopment. And the thing that I'd like to stress is that there are a tremendous number of requirements that are put in place that they have to observe to undertake this effort. And those requirements involve protecting the workers when they're doing this work, protecting the public while this is being undertaken, and also protecting the environment. And the process, and I think you're going to see some pretty amazing images, is a very thoughtful one where they review, they analyze, they plan, and then ultimately they implement the effort to sort of deactivate, remove the hazardous materials from the site, and then start taking the site down. And so part of that process is picking their monitoring locations. They do that for safety of the workers and for relevance to the public. And then they go through the process, this deactivation, decontamination, and eventually the deconstruction, if you will, decommissioning of the site. And then, again, the ultimate goal, of course, is to release it for redevelopment for the benefit of the community. Next slide, please. So in this brief little introduction, what I wanted to bring to your attention is that, the level of risk, what is acceptable, how it's regulated, varies depending on if your focus is for the worker or for the general public or people outside. The goal of this effort is not to eliminate all risk, but they reduce it down to a level that's acceptable for the workers, for the public, and the environment. And what you'll see woven through all the discussions today is that safety is absolutely paramount in this process. So thank you for the opportunity to present, and I'll be looking forward to your comments and questions.
Thank you, Dr. Higley. My name is Jeremy Davis. I'm the acting Portsmouth site lead here at the Portsmouth site, and I've got over 20 years experience working here. Also working at different sites across the complex. I'm a lifelong resident of Pike County. I've got a bachelor's degree in natural science with concentration areas in biology, chemistry, and geology. A lot of my experience has been focused on environmental program integration, facility oversight, environmental compliance, hazardous waste management, and project management. I'm a certified hazardous materials manager and a project management professional. So that's a little bit about me. Next slide. So if you're not familiar with the site, this is probably some good information. If you are, this is kind of the Portsmouth site history. It's a 3,700 acre federal site. Its uranium enrichment operations started in 1954. The primary focus at that time was during the Cold War. So the strategic goal was nuclear defense. And then post-Cold War from 1989 to 2001, the focus was commercial nuclear power and environmental cleanup. So the DOE cleanup mission began in 1989, and then full-scale D&D began in 2010. So that's where we are currently. We're in the process of performing environmental cleanup, as Kathy talked about earlier, decontamination and decommissioning, and subsequent demolition of the facilities. And then after that cleanup is complete, transfer of the property over to the local reuse organization, which is SODI, or Southern Ohio Diversification Initiative, for reuse by the local community. Next slide. So just to give you guys a quick update on what is our 10-year deactivation and demolition cleanup focus. So, I am happy to report since the last public meeting, we did complete the structural demolition of the first process building, which was the X326 facility. And then the next facility slated for demolition is the X333 and then the X330 process building. So we also have completed construction on the first 3 cells of the on-site waste disposal cell facility, and we hope to complete the remainder of those cells over the next 10 years to support the disposal and demolition of the structural debris here on site. We also will be excavating landfills and plumes within the perimeter road. That soil that is excavated from those areas will be used as fill to provide contiguous, or to provide the necessary compaction ratings for the construction of those grids within the OSWDF cells. And then that land will be transferred over to SODI for future economic development. So the transfer of land to SODI is a big priority for the department as we try to make those land parcels available for reuse by partnering industry. Next slide. So Kathy talked a little bit about the projects here on site, and I mentioned the 326 demolition. So I want to take an opportunity to talk about demolition safety planning. So this is something that was an extensive effort here at the site to plan the demolition of the first process building. Our target was a safe, methodical demolition plan. That plan was drafted, reviewed by PPPO, and then approved by Ohio EPA. As a part of that demolition safety planning, we utilized lessons learned from other decommissioning experience across the complex. So other sites like Hanford, Fernald, Oak Ridge, and things like other places like that. We pulled lessons learned from them and tried to ensure that we had a good plan that was safe and methodical to protect not only the workers but also the environment and thus our local community. So the first step in that demolition was to identify the hazards and remove them from the building to make it safe for demolition. So we looked at things like asbestos containing materials, friable asbestos, other chemical hazards. We also removed some of the process gas equipment from this facility prior to demolition. And then another thing that we tried to focus on was utilizing a trained and experienced and capable workforce. So as you can see from the picture on the right, this is the final section of the facility that came down back in June. We utilized a lot of 3-dimensional planning and things like that to determine how the actual cuts of that facility would be made to pull it down and protect the workers, and also ensure that the dust mitigation tactics that were employed were safe and effective. So lots of protective measures were used to minimize the disturbance of any of the residual radiological or chemical contaminants. So you'll see from that picture, you'll see a mist coming up from the right-hand side of your screen. Those were dust suppression devices. We call them water blasters. So they kept the work face of the demolition, wet to deter any dust that would be created from the demolition. And if you look back on the right-hand side of the pile and kind of the midsection of the photograph, you'll see a green tint on the demolition debris pile. That's a fixative that was added to the debris piles, and that's another dust mitigation tactic that's used to secure the radiological or chemical contaminants that could be on the structural steel. So as a part of that, or as a second tier to the protective measures taken, we also have a robust environmental monitoring program. That includes real-time monitoring and also sample monitoring that's done and collected and collaborated with other industry partners to ensure that we are seeing the proper effects needed to mitigate those hazards during demolition. Next slide. So demolition began in May of 2021. That structural demolition, like I said before, it was completed in June 10th. of this year, we generated approximately 135,000 cubic yards of debris. So that debris is being size reduced and sent to the OSWDF for disposal. The first step, as I said before, in the demolition was to remove the asbestos-containing material from the facility. And one of those asbestos-containing materials was the transite panels that were on the outside of the facility. So if you look at the top left, you'll see a big truckload of those asbestos-containing materials, the transite panels, which were double wrapped and then transferred to the OSWDF for placement within the, one of the cells. So those become a foundational piece of the grids that are constructed at the OSWDF. The next picture you see to the right is a picture of one of the track shears that's used to pull down the facility, size reduce the material, and get it ready to go to the OSWDF to ensure that that material meets the waste acceptance criteria for placement within the OSWDF. The bottom picture is a really neat picture, and that is from the south looking north, and that shows you there that how much work it took to pull this approximately 30-acre facility down and perform that structural demolition. I will call your attention to the debris piles. If you look to the north, you'll kind of notice that the material in those piles is a bit larger than the ones to the south. The ones to the south have been, size reduced a little bit more. You'll also notice that green tint that I talked about earlier. So that is that fixative that gets applied to those debris piles, after demolition is complete, and those fixatives help us control some of those fugitive dust emissions from the workplace. Next slide. So I talked earlier as well about the contaminated plume excavation. So when placing the debris into the cell, you also need soil to provide the proper compaction of the debris and the material to prevent subsidence. So that's about a 2.5 to 1 ratio. So we made a commitment for the cleanup mission to excavate contaminated plumes within Perimeter Road. The first one that we completed was the X740 plume excavation. That was an underground contamination plume of trichloroethylene. I'm happy to report that excavation was complete, and we were able to deliver over 40,000 cubic yards of soil and fill to the OSWDF. That soil was then replaced, and that area is now complete. And the area we're excavating now is the X231B plume excavation. So that excavation is anticipated to be complete later this summer, and that excavation will provide the remaining soil that we need to place the remainder of the 326 debris that you saw in the previous slide. Next slide. So I've talked a lot about the OSWDF, or on-site waste disposal facility. So this slide will kind of discuss, the special engineering and design that went into this disposal site. It is a multi-layer liner and cap system. It's designed to consolidate the demolition debris and rubble into one centralized location, so that when the deactivation and demolition is complete, you'll have that material consolidated in a safe configuration within this OSWDF. So I'll draw your attention to the white box on the bottom right hand of the screen. So if you look at that liner system, you'll notice that the liner system includes a compacted clay liner and also 2 layers of high density polyethylene, and then a protective layer on top of those, along with a select layer that provides the cushion necessary to protect the liner for the next 1,000 years, which is the design criteria for the cell. So when we talk about the capping system, you'll also notice that it gets a compacted clay cap along with a high density polyethylene barrier cap layer, and that will get covered with a drainage layer and then the drainage layer will be covered by a biointrusion layer, soils, and then vegetation. So this OSWDF is designed to accommodate more than 5 million cubic yards of waste and engineered fill from the excavation of the landfills and plumes and cleanup mission here. That disposal facility is divided into 12 cells. It takes about one process building, or it takes about 3 cells to contain one process building. So that will give us 9 cells to hold the 333, 326, and 330 facilities. And then we'll have one remaining cell for the support facilities that are around the site. Now, the other 2 cells will be contingency cells should we need additional capacity for other facilities on site that meet the waste acceptance criteria, or what we will need to place the remaining facilities here on site. So next slide. So I talked about in the protective measures slide about real-time air monitoring. So we talk about real-time air monitoring, but that's also coupled with our program, our air monitoring program monitors. So currently on the entire site, we have about 180 air monitors located on and off site. And those monitors are there to ensure that the project maintains the control of dust generated during demolition disposal activities, and also to ensure that we're protecting the workers, the local environment, and the community. So those monitors measure for radiological and non-radiological particulates. I'll draw your attention to the slide on the image on the right hand of the slide. And I want you to notice there's not only project air monitors that are specific to the 326. You'll see that there's those project specific monitors are located in and around that footprint. But you'll also see that we also have Ohio EPA and Ohio Department of Health co-located air monitors. So we worked in conjunction with Ohio EPA and Ohio Department of Health to also measure for radiological and non-radiological particulates. We do that in concert with them to provide an independent verification of the air monitoring results that we see. So those results are measured at varying intervals. We have some that are monthly, weekly, but we also, like I said before, have that real-time capability, which I'll talk about a little bit with the next slide. So the real-time air monitoring approach are those project-specific monitors. So the real-time monitoring provides the first line of defense during that demolition and then size reduction of the material from the 326 pad. So it gives us, hour by hour updates on fugitive dust emissions, radiological particulates. Those thresholds are established so that no emissions, we have thresholds established for those metrics that we're measuring in and around the project boundary. And those thresholds are established so that emissions at the project boundary meet established administrative limits that Kathy talked about earlier. So these thresholds provide assurance that the limits at the property boundary will be safe and compliant for the local community. This also provides the ability to immediately react to field activity and adjust those field activity and operations, adjust things like the dust mitigation tactics and things like that during the demolition and during the demolition and size reduction of the material on the pad. So we also look at things like weather conditions, which way is the wind blowing, how fast is it blowing, and that also gives us the ability to adjust our demolition tactics so that we're ensuring that that the metrics that are measured are within the acceptable limits. Next slide. So I am happy to report that the 326 building project-specific real-time monitoring trends to date are shared publicly. We share those weekly, monthly, and quarterly. We also consolidate those results annually with the annual site environmental report, or the ACER report. Having those co-located air monitors with Ohio EPA and Ohio Department of Health also gives us an opportunity to have independent verification from the data. They also can provide that data to folks in the public. And I'm happy to report that all the data recorded to date indicate safe control of not only the fugitive dust, but also other contaminants of concern. Next slide. So what's next after the 326 is complete will be to complete the deactivation of the 333 process building. It is the next building to be demolished on site. It's also the largest of the 3 process buildings. So it's approximately 66 acres of floor space with both the operations floor and the cell operations floor. So currently within the 333 process building, they are performing material sizing. So you'll see the picture there on the bottom left-hand side of your screen. They're currently pulling out bundles, size reducing them, packaging them for potential future reuse, and preparing the facility for demolition. So some of the components within the facility are being disassembled and being stored and getting ready for demolition and future waste placement in the OSWDF. Next slide. So another part of the mission I'd like to point out is the operations that are done at the depleted uranium hexafluoride conversion facility. So this is another part of the DOE cleanup mission here at the site. So if you drive around our site, you'll see lots of cylinders. So we're taking those cylinders into this facility and using the technology within that facility to convert the inventory of depleted uranium hexafluoride that was produced during the enrichment process. So that conversion takes the UF6 and converts it into a more stable uranium oxide. That oxide can potentially be reused. Some of it is being stored, and I'm happy to report that we are preparing for one of our first shipments of this material from the Paducah site here in the very near future. So that depleted uranium hexafluoride conversion facility is a big part of the cleanup mission here at the site. And we're happy to report they are in operations, and we're anxious to see what they can accomplish in the next few years. Next slide. So what is the future of the Portsmouth site? So what is the site reuse potential? Here at the department, we've implemented kind of a systematic approach to turning the parcels over to SODI. First, we looked at land that was not currently being used. So we identified parcel 1, which was approximately 80 acres. That has already been transferred to Southern Ohio Diversification Initiative. And then parcel 2, which is approximately 227 acres, will be transferred within this calendar year. And then we've also identified 48 acres, or parcel 3, in the upper right-hand side of your graphic there, that will be transferred in the very near future. So SODI is working to find industry partners and companies that are interested in maybe putting some type of industry here at the site. And the department is going to strategically move throughout the site and continue to turn land over to them as necessary. Next slide. So I did want to take an opportunity to talk about the community commitment plan. This is something that, at the department we're very proud of, and it's, something that's been a part of Fluor's contract since 2011. So that community commitment plan focuses on 4 main areas. So educational outreach, regional purchasing, so buying from local vendors, community giving, and economic development. So I'm happy to be a part of this. We do things like educational outreach, such as the ACER program, where local students have an opportunity to review environmental monitoring data from the previous year, consolidate that data and write a summary report that gets published in the ACER. We also see in the bottom picture there, the department supports the National Science Bowl. Lucasville Valley had an opportunity to go on to the regional finals for that competition. And that community commitment plan has been a huge impact to our local students, businesses, and communities. So over 16,000 students have participated in the educational outreach program. $550 million has been committed to local companies for goods and services. $2.9 million has been donated by Floor BWXT and its employees to local charitable organizations like the United Way and the local YMCA. $4.9 million has been invested in the local businesses or local community to create and retain jobs. And that's just since 2011. So next slide. I think that's the last of my slides. I'll turn it over to Frank, and he can go over some of the air monitoring data with you. Thank you.
Okay, thank you very much, Jeremy. I appreciate that. We are going to go through some of the data, some of the information relative to our air monitoring program has already been shared, so I appreciate Dr. Higley and Jeremy teeing some of that stuff up. The data that we're presenting is really just trying to answer the question of how are we doing relative to all the planning, all the design, all the controls that we put in place. So I certainly hope that you find the data that we are sharing with you today to be helpful and to provide you an assurance that the data and the project is under control and the data to date is supporting that. I will say that all the data that we are going to be presenting tonight is available online, and the websites where that data can be found will be provided at the end of my presentation. So my name is Frank Johnston. I am the Director of Environmental Protection for Floor BWXT. A few bullets there about my experience. I have over 37 years experience in the environmental field, 32 of which is on DOE sites doing the types of remediation and demolition and decontamination that is occurring at the Portsmouth site. I've got some experience in environmental management, environmental compliance, remedial designs, design and implementation and operation of a variety of control systems, air emission control systems, and industrial and municipal wastewater treatment facilities. Next slide, please. So you have seen on the right this map of our air monitoring before. You are going to see it several times again because it's really grounding us as to where the data that we're talking about, where it is collected. So this is a map of all the air monitoring stations that we have. We have project-specific monitors around the projects where, for instance, the 326 demolition is occurring, some of the landfill and plumes excavations where that's occurring, and also up around the on-site waste disposal facility. You've seen this windrows before. I won't belabor it. It's just there to indicate where the prevailing winds are for the Portsmouth site. This is evaluated annually. This is pretty consistent with the past years, but it's it indicates the prevailing wind direction and the intensity of the winds that are experienced at Portsmouth. So really the punchline here from this slide is just to recognize that we have a robust air monitoring system that is really layered. It begins with the project-specific monitors. We have several monitors that are removed from the project but on the property. And then we also have a variety of a number of air monitors that are at the property boundary as well as off property. Next slide, please. So you've seen this slide before. I want to reiterate just a couple points. Our overall philosophy is to ensure that any contaminants that we have from our projects, from the demolition of the 326, from our excavations, from our OSWDF operations, our overarching philosophy is whatever contaminants there are, we want to keep them within the project boundaries. The better we can do that, the more assurance we have that we're not having any impact upon the property boundary and our neighbors that are just beyond that. And this real-time monitoring certainly does give us that first line of defense. As has been mentioned, we have thresholds established that the data is compared to continuously. In fact, we get, if we happen to have an excursion of particulate matter, for example, myself and a number of people get automatic emails that tells us that there is an issue that needs to be addressed. We can apply more dust control. We can perhaps change our practices that we're currently implementing. And also, because we also monitor the weather, if the weather happens to be unfavorable, we can use that information to also to make adjustments or to pause work. Next slide, please. So this is the first bit of data that we'll share with you tonight, and this is from our real-time particulate monitors that are around the 326 project. Before I talk about the chart at the bottom, I want to talk about the lines that are just above it. The red line right in the middle is the National Ambient Air Quality Standard for particulate matter at the 10 micron level. That's 150 micrograms per cubic meter. Now, we have adopted that standard at the property boundary, but we compare our activities, for instance, here at the 326, to that standard. Again, trying to ensure that we are keeping all of the, to the degree we can, all of the fugitive dust and contamination on the project boundary itself. The two lines below that red line are administrative levels. I think Dr. Higley referred to them as, we call them action levels. That if we do approach or exceed those action levels, that we take some steps. We pause work, we gather the team together, determine perhaps why it's occurring, and what adjustments that we can make, all in the hopes to ensure that we are staying below that standard at the project. I'll point out that where we started the structural demolition, that was on May 17th, and we ended structural demolition on June 10th. Now, the chart below is the actual data. That is a continuous record of the 24-hour averages of particulate matter from about the mid-February of 2021 all the way through the beginning of July. That would include when we finished the structural demolition. You will see that there is some volatility in those readings, but they are all, have never exceeded any of those administrative levels, and certainly has not exceeded the National Ambient Air Quality Standard that we have applied. Next slide, please. And we also have real-time particulate matters located at the Department of Energy and Ohio EPA co-located stations. And there's a map of that in some slides later on in my presentation. But these monitors are removed from the project boundary. They are on property, but they are removed from the specific project activities. So they would be looking at particulate matter in a more comprehensive way, given all the site activities that are occurring. So once again, the red line there at the very top is the National Ambient Air Quality Standard, 150 micrograms per cubic meter. And then the chart below from about the January 21 timeframe, again through the beginning of July, is the actual data measured at these stations. It's again a graph of the 24-hour our averages of particulate matter. And this again supports our assertion that we are having a positive effect on controlling dust, even at these remote locations where other activities might be impacting these air monitors. Next slide, please. Another very important real-time measurement is real-time alpha measurements, radiological measurement. We have a number of these, what's called ICAMs, around the 326 facility. We have established a daily limit of 0.8 DAC hours, which is derived air concentration hours, that is established by our radiological engineers. And we compare the real-time readings that we are getting to that standard. The chart, the graph below, would indicate that we are far below that standard. I will say that standard is alarmed. If we happen to go over that standard, there is alarms that occur so that we can respond and remove folks from the project and take whatever actions we deem necessary should that occur. But we have not seen anything that is approaching that standard. Again, the graph below is far below that. I do have a couple call outs there just for information. I mean, we did begin this real-time monitoring for alpha when we began the demolition and loadout operations, actually a little bit before that. And then we show that all the way through the structural demolition that has been completed. There's a couple other call outs there just for information. You can see in the hot weather months in the summer where there's an increased air movement that we are getting a little bit more of a reading on our real-time alpha. You can see where we've added some additional dust destroyers. You can see right in the middle there, to about mid-December of 2021 timeframe, where we've suspended loadout operations because we shut down the on-site waste disposal facility during the winter months. Generally coincides with about mid-December through probably mid to late March timeframe. Next slide, please. So this is a picture in the bottom left. There is a picture of one of our dust destroyers that makes a tour around the entire slab. We've got a couple of those that are spraying, misting, and fixatives on these debris piles. And then the main picture there is, and this was taken, I believe, on the day that structural demolition was complete. I believe it was June 10th. I think a couple pictures that Jeremy showed shows some of those debris piles already gone. But this shows the demolition complete and all the debris that we now have to size reduce and transfer over to the on-site waste disposal facility for disposal. All the data that we've seen so far, the real-time data that we have seen so far that I presented here indicates good control of our fugitive dust. It's indicating that our water misting and our fixative applications are proving to be effective, and that our real-time alpha and beta measurements are protective of the workers and certainly been protective of the public at large. I will pause right here just to mention that all the real-time monitors that we have in place now and all the sampling devices that we have that I'm going to be talking about here in a little bit will remain operational until we have all of this debris removed from the slab. So we will still use real-time to continue to control our activities and continue to sample, as I'll describe later, until this debris has been disposed. Next slide, please. So we've talked about the real time. Now we're going to talk about some of the analytical sampling, meaning the samples that are collected and sent off to laboratories for analysis. And we have, and Kathy has indicated, Dr. Higley has indicated some of the things that we go through to design an appropriate air monitoring program. And one of those key things is to identify the contaminants of concern that we're dealing with. Um, as Jeremy indicated, the 326 facility went through an extensive, what's called a deactivation period from 2011 through 2020. It was during that period of time where hazardous waste were removed from the facility, oils were removed from the facility, PCB oils were removed from the facility, asbestos abatement activities occurred, processed gas equipment was removed. So there was a lot of waste and a lot of contaminants that through that effort were removed from the facility. But having said that, there still remains some residual contamination just due to the operational history of the 326 facility over its 50-plus year life. In addition to that residual contamination, there's contaminants associated just with the building materials themselves. The concrete, the structural steel, the paint that's on the structural steel, those types of things. So we wanted to ensure we understood what those contaminants were as well. So we went through and studied these, investigated the situation very thoroughly, and determined that that contaminants concern that I'll mention here includes the non-radiological contaminants, heavy metals, asbestos, volatile organic chemicals, and polychlorinated biphenyls, PCBs. And it also includes the radiological contaminants such as uranium and technetium. Next slide, please. So we have an understanding now of the meteorological conditions with the wind. We have a list, a comprehensive list of air contaminants or contaminants of concern. And now we have the ability with that information to make some assumptions on operations and to model those operations to see what the impact of those contaminants relative to our operations would be. So during the design phase of the 326 demolition facility, there was a comprehensive air modeling report or air modeling effort that was put together as part of that design process. That report was very important to us. It was it basically told us that we were able to accomplish the things that we needed to accomplish and stay in compliance with the Clean Air Act as well as all the Department of Energy standards for radiological emissions. This report was peer reviewed by an independent expert retained by FBP. The Department of Energy reviewed it, and they also retained their own independent expert and reviewed this air modeling report. This report was provided to Ohio EPA, who concurred with it back in May 20 of the year 2020. That modeling report talks about the shows that all the air emissions calculations, the air dispersal modeling results. And one of the important keys to that is it not only looked at the individual sources, but it looked at the cumulative impacts from all the planned activities that we were going to be undertaking. That includes not only the demolition of the 326 facility, but it also included the impacts from the groundwater and soil excavations, as well as the OSWDF operations. Next slide, please. I should have mentioned one of the things that air modeling report did for us is also help us define where the appropriate air monitoring locations were going to be. And this slide is indicating, again, where these air monitors are. And we'll break this down as we go through. But if you remember back to Dr. Higley's presentation with the chart, the map that showed a bullseye, our bullseye is the 326 demolition facility. It has 8 air monitoring locations around it. The Department of Energy and Ohio Department of Health co-located stations are 18 such stations, both on and off property. And then there are also 5 Department of Energy and Ohio EPA co-located stations. Next slide, please. Jeremy mentioned this, and I will reiterate that it's to great credit to Department of Energy, Ohio Department of Health, and Ohio EPA to collaborate on this very important thing relative to our air emissions and air monitoring. These co-located stations provide a redundancy in the air sampling to help confirm the air emission impacts from on and off site activities, and they're consistently measured. It provides the regulators and the public of an independent mechanism to evaluate all the air data that is collected, and hopefully increasing the confidence in the data that's collected and reported and made available online. And it just provides an increased level of transparency, not only with our state regulatory agencies, but with our other stakeholders and our neighbors. Next slide, please. These are examples of the air monitoring stations that we'll be talking about. On the left-hand side are the Ohio EPA Department of Energy co-located stations. There are 5 such stations located on the property. We use these stations to monitor for the non-radiological parameters, including the particulate matter that we have already discussed, volatile organic chemicals, heavy metals, asbestos. The data is gathered and analyzed, validated, independent from DOE, and the data is published quarterly. The data that we're going to talk about as we progress here, by the way, is Department of Energy data. It is, like I said, analyzed and validated independently. DOE does their thing. Ohio EPA has their process. And the data is all published quarterly. For DOE, it's published on what's called their Pegasus website, and Ohio EPA also publishes it on their own website. Again, I'll have those websites for you at the end of my presentation. On the right-hand side is the example of the Ohio Department of Health and the DOE co-located stations. There are 18 such locations on and off site. This is where we monitor for radiological contamination. We also monitor for fluoride. I have an asterisk there just to highlight that the Department of Energy samples for fluoride at these locations, but the Ohio Department of Health does not. Similarly to what Ohio EPA does, the data is gathered, analyzed, and validated independent of DOE. The data is also published quarterly. That data, the radiological data, is published again on the DOE Pegasus website, and the Ohio Department of Health has their own website to which they publish this data. Next slide, please. So the first thing we'll talk about here is the non-radiological sampling. This is a map on the left that shows the locations of these air monitoring stations. You will see our bullseye there in the middle in the red outline. That's the 326 facility, so you can see in relation where these air monitors are. We sample for heavy metals on a weekly basis at each of these locations, including antimony, arsenic, beryllium, cadmium, mercury. All of these are sampled on a weekly basis. We also sample for volatile organic compounds at these locations. Primarily, the VOC that we're concerned with is trichloroethylene. It was used as a wide use on site as an industrial solvent during the operational history of the Portsmouth site. We sample for those volatile organic compounds on a weekly basis as well. Because there was so much asbestos, and we did go through an extensive asbestos abatement, it is still a contaminant of concern, so we do continue to monitor for fibers, asbestos fibers, on a weekly basis at these locations. Next slide, please. So while we do all the sampling for these variety of contaminants of concern, we needed to develop what a protective level would be to which we could compare all the sampling results that we are accumulating. And the protective level that we have determined is what's called the maximum acceptable ground level concentration, or MAGLIC. We apply this protective level, this MAGLIC, at the property boundary. This is used as the basis for comparing all the non-radiological air monitoring data that we get. The maglic is a calculated value based on exposure for particular elements, heavy metals, as well as volatile organic compounds, threshold limit values from OSHA, as well as the American Conference of Government Industrial Hygienists. That's where the exposure part of the maglic calculation comes from. And then the other part are the operational assumptions that are built into this calculation. As I said, this maglic is applied at the property boundary, but we use it at other locations. Again, this overarching philosophy is to compare at the project level where our sampling results, so that we ensure that we're not impacting the property. The use of the maglic and the associated calculations were presented in the air modeling report and was approved by Ohio EPA back in May of 2020. Next slide, please. Now, I will admit that this chart is going to be a little bit difficult to read. We have a wealth of data, and one of the challenges is how to communicate that without boring people to death with just number after number after number. So what we've attempted to do here is to present the maximum detections that we have seen for our contaminants of concern as a comparison to the maglic. So let me explain this what we call a bubble chart a little bit further. Across the top there is the contaminant of concern that under consideration. For instance, the first gray dot is antimony, and then you'll see the rest of the heavy metals, and at the very right hand, it's the trichloroethylene, TCE. Underneath the name of each of the contaminants is the maglic, the calculated protective level for that parameter. On the left-hand side are the air monitoring stations that we're talking about. This is A50, A51, 52, 53, and through 54. Now, the actual bubbles that we're seeing represent the percentage of the maximum detected amount as a comparison to that protective standard, or the maglic. For instance, if you look at beryllium and you go down to station A51, which is in blue there, the maximum detection we had for beryllium was 17.7% of the maglic standard. Similarly, if you keep going down to A54, you will see again for beryllium, the maximum detected amount was at 21 point, I believe that's 8%. I don't have my glasses, but you get the point. So again, approximately 21% of that standard. All of the other bubbles represent just that. It's a percentage of the maximum detection compared to that protective level, or the maglic. This chart is really indicating that in many instances, the contaminants, the concentrations that we are seeing, are just fractions of the protective standard that we have established. Next slide, please. This is the same. This is the same chart. The only difference is that this represents the average detections rather than the maximum detections from the previous chart. This is the average of the detections. So they're all a little bit lower. I won't belabor this any further, but again, it just indicates that the metal and the VOC detections are significantly below the protective level, the maglic values that we have adopted. Next slide, please. I also mentioned that we sample asbestos, we'll sample for fibers and asbestos on a weekly basis at these locations. We do not have a maglic calculated for asbestos fibers, but we do sample them for weekly, as in addition to all under our industrial hygiene program, all the sampling that we do for asbestos within the project boundary. We sample for fibers as I indicated, and if we happen to see or get some detections of fibers, we then have those fibers analyzed to see if those are asbestos fibers. We use NIOSH-approved analytical methods, and just like we do for all the other samples we do, we send all of these results off to an independent laboratory for analysis. And to date, we have no indication of asbestos fibers at any of these DOE and Ohio EPA co-located monitoring stations. Next slide, please. Now we can talk a little bit about the radiological sampling that's conducted. And again, you will see on the right-hand side our map showing where these sampling stations are located. Again, our bullseye there is the 326 demolition facility. You can see that we have a number of air monitors throughout the property, as well as off property. We sample for a number of radionuclides at these locations. We sample for transuranics on a quarterly basis. That includes americium-241, neptunium-237, and some plutonium isotopes, 238 and 239, 240. We sample for thorium isotopes on a quarterly basis at these locations. We sample for total uranium and uranium isotopes on a monthly basis at these locations. And then we also sample for technetium-99. Next slide, please. So this is the second time you'll have seen a periodic table of the elements tonight. Wanted to show what the transuranics, what that really means. Transuranic elements like neptunium, plutonium, and americium are heavier than uranium and are listed after uranium on the periodic table of the elements. Neptunium, plutonium, and americium have been continuously monitored at the ambient air monitors in and around the Portsmouth site since at least the mid-1990s. There have been, on occasion, detections of transuranics at these locations. These are reported, and if there are detections, explained in the ACERs. But these go back, again, many years that we have been doing the sampling, and all of whatever, if we've had some detections, they have been very, very far below any regulatory limits. Next slide, please. So, transuranics at these locations sampled during our project activities beginning in February of 2021. We have not detected any transuranic isotopes at any of the co-located ambient air monitoring locations to date. And that's data that is collected through April of 2022. That is the most recent validated and available data to us at this point. Next slide, please. This is a chart that I'll take some time to explain. There's a couple charts following this that follow the same format. This is for thorium isotopes. Along the horizontal axis is the air monitoring station in question. And they're listed from the ones that are closest to the X326 facility, which would be the A52 monitor, to the furthest away, which is the A37 monitor. I've included here lines for the individual isotopes derived concentration standard. That is the protective level the Department of Energy established for these particular isotopes. The big chart shows the data in comparison to those standards, which you can't see. They're all essentially around zero. So with that said, we've included an inserted chart at a much smaller scale just to show you where the detections and to what concentrations they are, just to be a little bit more transparent. But again, the detections for thorium isotopes that we have had for data collected through April 2022 have been far below the derived concentration standards established by the Department of Energy. Next slide, please. This chart is laid out in a similar manner, and this is for total uranium. There is a derived concentration standard that we use for the uranium-238 that we use for comparison purposes. Again, if you looked at all the data and you compared that to that standard on the big chart, they would all essentially be right around 0. So we have included an inserted chart that, again, at a much smaller scale, shows where we have detected and at what concentrations the maximum concentrations of uranium has been detected. And this is also from data that is collected through April of 2022. The uranium data that we are seeing, again, is far below the derived concentration standard that has been established for uranium. Next slide, please. And then again, for technetium-99, the same layout for this slide. The derived concentration standard for technetium-99 is 2,000 picocuries per cubic meter. If you looked at all the data at the scale that compares the results to that standard, they would all be, again, right around 0. But we have included the inserted chart that shows the maximum detected concentration of technetium-99 at the air monitoring stations. Again, the takeaway from this slide, as in the others, is that the concentrations that we're seeing are far below the protective standards that have been established. Next slide, please. So, in summary, just looking at the co-located air monitoring program, what we're seeing is, and again, all of this data is posted on the websites that's listed below, but what we're seeing is that the sample results that is collected by DOE is consistent with those that are collected by Ohio EPA as well as the Ohio Department of Health. They're never going to be exact, but they are very, very consistent. If you go to the website and you look at this data, you will see where some data is flagged as maybe a bit too much variability, or a little bit out of spec. So it's shown there where there are some inconsistencies. But by and large, all the data is very consistent with one another. The real punchline is good news, is that all of the data that we've been collecting so far is far below the regulatory limits, and is showing that our activities are being conducted in a way that is protective of not only our workers but human health and the environment. I have listed there the websites. I mentioned the Pegasus website. Ohio EPA has their website where they post their data, as well as the Ohio Department of Health. With that, that concludes my presentation, and I will turn it back over to our host, Eric.
Hey, I want to thank not only Frank, who did a great job walking us through some dense material there, but also Jeremy and Dr. Kathy Higley as well for sharing with us a little bit of their expertise and knowledge as pertaining to the Portsmouth site, air monitors, the demolition and the work going on, as well as understanding and managing risk. So thank you to the three of you for doing this. All right, so looking at the clock, I have 7:23. We are going to take a short break. Let's come back, everybody. We will reconvene at, let's do the bottom of the hour. Let's do 7:30 Eastern time. We will reconvene, and then we will look at a couple of the questions that we've had sent forward, and we'll do any Q&A at that point. So get up, stretch your legs, get away from your monitor for just a second, and we'll be back at 7:30, which is just over 5 minutes from now. right, folks. Hey, welcome back. I've got 6:30, and so we're going to go ahead and reconvene and get, or 7:30, excuse me, and reconvene and get ready to wrap up our festivities this evening. Again, I want to thank you for joining us, and we did have a few folks watching online with our YouTube stream. We had a few folks here on the Teams platform, so we're glad to have you, whichever avenue you're using, and of course the YouTube feed will stay up indefinitely, so you can always go back, check that out, and see the evening and see our presenters. In addition, you can download the presentation from tonight. I know that there was a lot of information, and if you're looking for a little light evening reading, right, Jeremy, you can go back and download the presentation and make your way back through all the slides and get to it. So we did have one question submitted tonight on YouTube, Jeremy, and I want to give you a chance to speak to that. The question, and maybe one of the most important questions to be asked is, are the air monitor results provided or available to the public?
Yeah, so that is a great question, and one that we want to make sure we drive home with these meetings is that air monitoring data is available to the public through that portsdemo.com. So you can go to the portsdemo.com. You can scroll down to the bottom of the page. There's links there to weekly, monthly, and quarterly data. Those links can take you to another website, which is the Pegasus website, pegasus.ports.pppo.gov. So those results are available to you. Then you also have access to Ohio EPA and Ohio Department of Health websites as well. And you'll see those links in the presentation. So if you want to download the presentation, you can find those websites, and you'll be able to pull that data up and review it as a member of the public. So yeah, so great question. There again, we want to make sure that you know that air monitoring data is available to you. And I'll add to that as well. So we also consolidate all the environmental monitoring data into the annual site environmental report. So those are also available to you as well. So yeah, so great question. I hope that answers the question, and happy hunting for that data. It is available to you. I've been on that system to look at the data myself. So good question.
Hey, thanks for that answer. And I love the fact that not only are there multiple places you can go and search out the data, but you can also see collaborative or corroborating data from Ohio EPA, Ohio Department of Health, and really crosswalk between the Department of Energy's data as well as what the regulators are seeing. And I guess it would be remiss if we didn't remind folks that while you're looking at the data, if you come up with questions, if you need clarification, or you have any follow-up thoughts or discussion, you can always submit questions via email to us, and we will try to get those up in a timely fashion, respond to those as quickly as possible. ports-demo-questions@pppo.gov. ports-demo-questions@pppo.gov. And it's not uncommon for us to get questions in the interim between meetings, between the Tuesday, Thursday meeting, or sometimes even after the Thursday meeting on these quarterly meetings. Had time to think and process, and a question pops in your head. So don't hesitate to send those over, and we'll see if we can't respond to those. And you can find those answers to those questions on portsdemo.com. So with that, we're going to slide forward into our public comment session for tonight. So if you are on the Teams chat, unfortunately there's not a way for folks watching on YouTube to participate, but if you're on the Teams chat and you would like to participate in the public comment portion tonight, I'm going to ask that you look at the on your Teams platform, and there should be a reactions button, and it looks like a smiley face, a little emoji with a hand in front of it. And if you can click on that button, it'll give you a couple choices, a little thumbs up, a heart, a smiling face, and there's also a hand. So if you can find that button and raise your hand, it will identify that you would like to speak. And then we can go through that and take just a second and we can open up your microphone and allow you to provide comment for tonight's session. Hey, while we're waiting, this is one more chance to say thanks again to Kathy Higley and Frank Johnston and Jeremy Davis for their time and effort. A lot of effort goes into trying to communicate. These are difficult and complicated subjects, a lot of depth and nuance to them. So finding the cleanest, most efficient way to communicate this in what can be a difficult format. You know, the virtual platforms, you lose a little bit of the face-to-face and you get that feedback on whether things are being processed. And Jeremy, Frank, and Kathy do a great job in educating and sharing their wealth of knowledge with us, and I want to thank them for that. All right, I am not seeing anyone volunteering for tonight's public comment session, so we're going to wrap this up. I want to say thanks again to our speakers. Thanks to the folks that helped present the meeting. Thanks to all those who participated online by watching and viewing, and we appreciate it. Don't hesitate to send us any questions you might have, ports-demo-questions@pppo.gov. Thanks a lot for your time and attention, and we will see you all soon. Thanks. Have a good night.
Thanks, Eric. Good job.
Great job.